All right, so this definition of derivative review, we're going to use the two definitions for derivatives. The one that we use most often, the limit as h goes to 0 definition, and then also the alternate definition for the derivative. So what the AP test does is they don't ask you, like I did in class, they don't say, find the derivative of this function by using the long way, like using the definition of derivative. They do not do that, okay? So I know you guys all thought you would have to do that on the AP test. You actually don't. So the types of questions that they will have is it's kind of like in the middle of the problem, okay? So it says, as a quick refresher, find the derivative at x equals 2 using each definition. Let's go ahead and do that, I guess, and then we'll talk about where we're stuck in the middle of it. So if I'm finding the derivative of x squared minus 3x plus 5, so you might want to write a little tiny, we'd have the limit as h goes to 0 of f of x plus h, and our x value is 2, so I'm going to do 2 plus h minus f of 2 all over h. So I'd have the limit as h goes to 0, and I'm plugging in my 2 plus h for my x. So I'm going to have 2 plus h squared minus 3 times 2 plus h plus 5. Then I have minus my f of 2. So what is f of 2? 4 minus 6 plus 5? 3? So we have minus 3. I'll just go ahead and put 3 there instead of writing it all out. And then all over, the denominator is just h. So that's when we simplify everything. So we FOIL everything out. So I get the limit as h goes to 0. When I FOIL the first part out, I get 4 plus 4h plus h squared. And I have minus 6, and then minus 3h, and then plus 5 minus 3. And remember we said if you did this correctly, a lot of things will end up going away. So we have the 4 minus 6 is negative 2, but 5 minus 3 is positive 2. So it's gone. And the h goes into all pieces of the numerator. So we get the limit as h goes to 0. And we have 4 plus h minus 3. So our answer then is 1, right, as we plug in h goes to 0. Okay, do you guys all remember doing that?
Where'd you get the minus? Oh,
I brought this into each piece, so I just had minus 3 on the end. All right, and so the next one was the limit as x goes to that a value, to 2. And we take our f of x function just as it is, x squared minus 3x plus 5, and we subtract out whatever f of 2 was. Well, we found f of 2. F of 2 was 3. And then we divide by x minus 2. So this is basically the same thing. It's just saying as your x value gets closer and closer to 2. So you take a certain x value and then you slide them together. It's still the slope between f of x, or x comma f of x, and 2 comma f of 2. All right, so as we do this, we get limit as x goes to 2, and we have x squared minus 3x plus 2, and then all over x minus 2, which then factors. So this is why we did all those limit problems. So we factor x minus 2, x minus 1 over x minus 2. And we're not plugging in h equals 0 now, we're plugging in x as it goes to 2, right? So as we plug in x and we replace it with 2, we get 2 minus 1, which is also 1. Okay, so that's kind of a quick refresher of these two definitions. Do we feel comfortable doing that? Yes. So like I was saying, the AP test doesn't ask you to do that. They don't say use the definition of derivative to find these things. It kind of gives you a problem in the middle of a definition of derivative problem, okay? So it says there are more challenging questions involving the definition of derivative on the AP exam. So this is why you had to memorize these formulas at the beginning of the year. So I'm not using my notebooks. These are going to slide, so I'm going to have to clear my ink. I think I can do that. Maybe not. All right, so it says find the values of the following. So when you look at these first two, so looking at number 1, do you guys recognize that that is set up as a definition of derivative problem? Do you see the h? Limit as h goes to 0, okay? This is in the form limit as h goes to 0 of f of x plus h minus f of x all over h. It's in that form. So that means that all of this is going to equal f prime of some number, f prime of whatever our number is. Do you guys have any guesses on what our x value is? It's 5, yeah. We're finding f prime of 5. All of that is equal to f prime of 5. That's all equal to f prime of x, right? So the key is to identify what your function is, right? We don't want to have to do this whole limit thing. You guys know how to do this without doing this trick. But now that you know derivatives, we can do it even faster, especially for really, really hard ones that we don't know how to multiply out. And we'll talk about some of those. So we need to identify our f of x. Okay? It should be right here. You see it? F of x is x to the negative 1, exactly. Do you guys all see that? So f of x is x to the negative 1. So what we're asking for is f prime of 5. So that's what we're finding, f prime of 5. That's all that this question is. It's just f prime of 5. Well, do we know how to find the derivative of 1 over x? Or x to the negative 1? Sure. What's its derivative? Negative 1, x to the negative 2, right? Negative x to the negative 2. Or in other words, negative 1 over x squared. So if I'm plugging in 5, right, because this is negative 1 over x squared, I guess we should write it like that. If I plug in 5, I get negative 1 over 5 squared. My answer is negative 1 over 25. So this is another way of doing the limit problem. Could you have done this? Like 1 over 5 plus h, right? We've done that before. We've done it this way, the long way. 1 over 5 plus h minus 1 over 5 all over h. And remember, we've gotten common denominators. We multiplied by 5 over 5, 5 plus h over 5 plus h. We were always, always good, and we multiplied that negative n, right? You remember all this. And we would get the same answer. We would also get negative 1 over 25. So it's recognizing that this is a derivative. It makes it a little bit faster. So on the next one, is this in the limit as h goes to 0 form? No, this is in the alternate form, right? So it's the limit as x goes to a, f of x minus f of a all over x minus a. So we can at least identify what a is, right? We got that. A is 2. Can you guys identify what f of x is? This one's the easiest one. It's exactly what was here. Do you guys see it? X squared minus 6 cubed. Is f of 2 equal to negative 8? Let's try. 2 squared minus 6 cubed is negative 8. Do you guys see it? So what we have is, this was the f of x, the part that's circled is f of x, minus f of 2. Do you guys see how f of 2 was negative 8? So minus a negative 8 is plus 8.
How did you know that? 2 is...
How did I know it was going to be negative 8? Well, I knew, well, at first I just found it, right? I plugged it in.
Yeah.
But I knew that the second part of the equation, so this was f of x minus f of 2. So since it said plus 8, I knew that it was going to be minus 8. So you guys are going to get good at recognizing these forms. Yeah?
Can we use x to 2, like on the, under the limit?
Yeah. We used that to identify what our a value was, right? That it could possibly be in the alternate form. And it is. It's in this alternate form. So could you waste a bunch of time and like do x squared minus 6 cubed, multiply it all out, plus 8, and then factor? You could. It would be a really hard problem though. This is actually pretty tricky.
Wait, so why aren't we finding f prime?
So that's what we're going to do. So we're going to, this is all equal to f prime of a, right? By our definition. So what we do is we say all of this original problem is really equal to f prime of 2. So that's all we're finding. We're finding f prime of 2. So f prime, I guess we haven't talked about the chain rule yet. That would make this a little easier. So we would have to FOIL this out, which is a little tricky. We're going to talk about the chain rule in the next section. So I guess I showed you this too early. I'm going to show you what it is. All right, we'll just write that. The next section is chain rule. Hopefully I don't have any homework problems like that. Maybe I should look through. All right, so, and then we're going to plug in 2. So I'm going to have f prime of 2 is equal to 3, 2 squared minus 6 squared times 2 times 2. So we're going to have 3. We have 4 minus 6 is negative 2. Negative 2 squared is 4 times 2 times 2. So I get 12 times 4, which is 48. So this answer is 48. So you can do all the limit stuff we did before, or you can recognize that it's one of those two derivative forms and just find the derivative. Okay, one more. It's squared for the derivative, yeah. I told you we haven't quite learned the chain rule yet. Do you guys see where the chain rule comes from? So basically you take the 3, you pull it to the front like you think you do. You write the inside part. You square it now, right? Subtract 1 from the power. But we have something called a chain, which is the derivative of what was inside. So the derivative of x squared minus 6, the derivative is 2x. So that's where that comes from. So we'll talk about that soon. All right. Oh man, all my writing moves. All right, so let's do the next one. So which of the two forms do you think it's in? It's in the alternate definition. Can you identify what f of x is and what our a value is? Yeah, f of x is the square root of x, right? A is 9, right? X goes to 9. So what are we finding? This is all equivalent to f prime of 9. That's all we're finding, f prime of 9.
You find f of x just by looking at the first term.
Yeah, when it's in that alternate definition form. But when it's not in the alternate definition, you actually look at the second part of it. Because it's not the x plus h. Are we what?
So like the first one of yours without the algebra.
Right. So this is going to be x to the 1/2. So what's the derivative of x to the 1/2? 1/2 x to the negative 1/2. So we're going to plug in 9 for our x. So we get 1 over 2 times 1 over the square root of 9, which is 1 over 6 is the answer. So see how it just makes your life a little bit easier on the AP test when it's kind of like in the middle of the problem. So there's one that was on there a few years ago that was like crazy. It involved, I think I put it on here. Yeah, it was this. And there were people that like wasted time and tried to FOIL that out 7 times. That is crazy. Don't do that. Like, look at that. That's insane. Don't multiply that out 7 times. Just know that your function is right here. 8x squared. Take the derivative of that and then plug in your a value. Does that make sense? You guys see it? So if you can make your life a little bit easier, then go for it. So recognize what your x value or your f of x is. All right, so the other assignment that you guys have is the equations of tangent lines practice. So let's look at that. So there's one last example that I haven't done yet, so I should really add this to the notes. Okay, so occasionally you have problems that say things like there are 2 tangent lines to the curve y equals 4x minus x squared that go through the point 2, 5. Now 2, 5 is not on the curve. So you could sketch this curve out if you want to. It would look like 1, 2, 3, 4. I think it's a downwards parabola like that. And then 2, 5 is not on that curve. So let's say 2, 5 is up here. Right? There would be 2 lines that are going to be tangent to the curve, so barely touch the curve, that go through that point. Does that make sense? How there can be more than one if you're off the line. Okay, I don't know exactly what the, let me think. So x, 4 minus x. Yeah, that's what the picture would look like. All right, so you don't have to know what that picture looks like. It's fine if you can't sketch it out, especially with the harder polynomials. But here's what we're going to do. If we're going to be, so it talks about tangent lines to this curve. So whenever it says tangent lines to a curve, what do you always do? Find the derivative, right? So we do 4 minus 2x. That is the slope. And it goes through the point 2, 5. So yes, we have the slope. We cannot plug in 2 for that slope, okay? We don't know where this is touching. It's not at the point 2. Mine looks like 0, 0, but I don't know. Wouldn't that be nice if I drew it perfectly? So you cannot plug in 2 because it's not on the curve. So that point is not on the curve. No, this type of problem you're not going to be plugging in. Because a lot of times I say find the tangent line at the point x equals, at the x value of 5. But I'm talking about on the curve. This point isn't anywhere, like it's not anywhere close to that curve, right? So we can't plug in 2 to find that slope. So what do? We leave it as our slope. So when we do our y minus y1 equals m times x minus x1, we just go ahead and we plug in 4 minus 2x like that. Weird, huh? And then we have x minus, and then we have x1 is going to be 2. y1 is going to be 5. And then we do one more thing. Because right now we have an equation with x and y. How do we solve this? I don't know. We don't know what these points are that it's tangent to. I mean, it could be right there. We don't know where it is. Okay? But we do know that it's on this curve, so it's going to be in the form x comma y. But what's y? 4x minus x squared. All right, I drew it so it looks like 0. I don't know where it is. So maybe I should draw it a little bit more exaggerated. Maybe it's right here, and here's 2 comma 5. Right? It could be tangent right there. We don't know. So x comma 4x minus x squared. That's what we're going to plug in for y. So we're going to have 4x minus x squared minus 5 equals 4 minus 2x times x minus 2. And you know how to solve something like this. Yeah, Katie?
Where'd you get the minus? Well, I know where the 5 comes from, but why'd you? Oh, so
Because that's the y, right? And then minus 5 still. So we want everything to be in terms of x. So we simplify. So we have 4x minus x squared minus 5 equals 4x minus 8 minus 2x squared plus 4x. And we get everything on one side. So we're like, okay, I have negative 2x squared. I'm going to add it to the left-hand side. So if I add 2x squared, then over on the other side, I'm going to have positive x squared. Or positive x squared. Running out of room. Don't want to move all my ink here. So x squared, and then I have 4x plus 4x is 8x, but I'm going to subtract it over. So I have 4x plus 4x is 8x. Subtract 8x over. What do I get? Negative 4x, yep. And then I have negative 8. I'm going to add it over. I get plus 3 equals 0. So x squared minus 4x plus 3 equals 0. And then I factor. So x minus 3, x minus 1 equals 0. So I get x equals 3 and x equals 1. Okay, we are almost done, but the question said find the equations of both lines. Yeah, so plug them into the slope to find m. So annoying. I have like no room. All right, so I'm going to plug in to find m. I'm writing it over here. So for x equals 3, my slope is 4 minus 2 times 3. So I get negative 2. What's my y value? Where do I go to find my y value? Back to the original, right? So I have 4 times 3 minus 3 squared. So I get 12 minus 9 is 3. So I have the slope of negative 2 through the point 3 comma 3. So it's going to be y minus 3 equals negative 2 times x minus 3. That's the first equation. And then the same thing for the second one. So I have x equals 1. So I find my slope. So I plug into my 4 minus 2x. So when I plug in 1, I get 4 minus 2 is 2. And then I plug into the y. So when I plug in y, I get 4 times 1 minus 1 times 1 squared. So 4 minus 1 is 3. So I have y minus 3 equals 2 times x minus 1 as well. And those are my two equations. Usually one has a positive slope, one has a negative slope, right? All right, does it make sense? So those are tricky. So it's kind of the hardest ones in those. All right, now the rest of them on that worksheet are ones that you have pretty much done before, except for there are some like that. So like number 1 is easy. You find the equation of the tangent line to the curve, right? That means you're just finding the derivative and plugging in 1. So is that x equals 1?
Just to the cure.
What did I?
Yeah,
Oh, to the cure. I typed this really late last night. All right. What else? So yeah, most of them I think you guys know how to do, but then there are some that are a little bit tricky. And then I put another table problem. So let me clear all this. Here, ink. I'm going to go to the bottom. So I do have a table problem. So these are just like the ones we did at the beginning of class because I had people that were asking me about this in the other class. So you do the product rule, quotient rule, right, to find the derivatives, and then use the information in the chart. Some of these points are giving you like an actual point. Some of them are giving you the slope, right? So think about it. So how would you find the equations of the tangent line or the normal line or whatever? Do you guys remember normal line? A normal line is when you have your tangent line and then you go perpendicular to it. So whatever slope you have, take the opposite reciprocal of it. Okay? All right, so you guys can work together.